Have you ever wondered how a company that started in a Denny's diner became the most valuable in the world? Today, we're diving deep into the incredible story of Nvidia, the company that's powering the AI revolution. It's a journey of vision, near failure, and relentless innovation. Let's rewind to 1993. Three engineers, Jensen Huang, Chris Malachowski, and Curtis Priem, met at a Denny's in San Jose, California. They saw a future where computers would be more than just tools for spreadsheets. They envisioned a world filled with rich, interactive 3D graphics, a world that needed a special kind of processor. At the time, the PC industry was dominated by CPUs, the central processing units. But our trio believed that for realistic graphics, you needed a dedicated graphics processing unit, or GPU. With a $40,000 investment, Nvidia was born. Their big idea was this. While CPUs are great at handling tasks one by one, GPUs are designed for parallel processing, handling thousands of tasks simultaneously. Think of it like this. A CPU is a brilliant professor who can solve complex equations one after another. A GPU is an entire army of students, each solving a small part of a massive problem at the same time. This parallel structure is perfect for rendering the millions of pixels that make up a 3D image on your screen. Nvidia's first product, the NV1, launched in 1995. It was ambitious, trying to integrate graphics, audio, and a game port all onto one card. But it was a commercial failure. The market wasn't quite ready, and the technology was complex and expensive. The company was on the brink of collapse, with only enough cash to survive for about a month. This early brush with disaster taught Jensen Huang a crucial lesson. Focus and execution are everything. So they went back to the drawing board. In 1997, they released the Riva 128. This time they nailed it. It was a pure 3D graphics accelerator that offered incredible performance for its price. It put Nvidia on the map and provided the financial runway they desperately needed. Gamers loved it, and suddenly Nvidia was a serious contender in the burgeoning graphics card market. The real breakthrough came in 1999 with the GeForce 256, which Nvidia marketed as the world's first GPU. This wasn't just a marketing slogan, it was a statement of intent. The GeForce 256 brought hardware-based transform lighting to consumer PCs, a feature previously found only in expensive professional workstations. This meant more realistic lighting and more complex 3D models in games. The GPU was born, and the PC gaming world would never be the same. The early 2000s were defined by the graphics wars. Nvidia and its main rival, ATI, were locked in a fierce battle for dominance. Every few months, they would one-up each other with a new, more powerful card. Remember the GeForce 3? It introduced programmable shaders, giving developers unprecedented control over visual effects. This was a massive leap forward, allowing for things like realistic water, dynamic shadows, and complex surface textures. This intense competition fueled incredible innovation and rapidly pushed the boundaries of what was possible in real-time graphics. But Jensen Huang's vision extended far beyond gaming. He realized that the parallel processing power of GPUs could be used for more than just making games look pretty. It was a general-purpose computing engine in disguise. This realization led to one of the most important developments in modern computing history. In 2006, Nvidia launched CUDA, which stands for Compute Unified Device Architecture. CUDA was a revolutionary platform that allowed developers to program the GPU using familiar languages like C. For the first time, scientists, researchers, and engineers could easily tap into the massive parallel power of the GPU for scientific computing, data analysis, and complex simulations. This was the moment Nvidia began its transformation from a gaming company into a general-purpose computing powerhouse. Initially, the adoption of CUDA was slow. The scientific community was used to working with CPUs. But a small group of researchers in a niche field called deep learning saw its potential. Deep learning models, which are a type of artificial intelligence, involve training vast neural networks on enormous amounts of data. This process requires a staggering number of parallel calculations, a task that was painfully slow on CPUs but perfectly suited for GPUs. The turning point came in 2012. A team of researchers from the University of Toronto, led by AI pioneer Geoffrey Hinton, used NVIDIA GPUs to train a deep learning model called AlexNet. They entered it into the prestigious ImageNet competition, a challenge to see which AI could most accurately identify objects in a million different images. AlexNet didn't just win, it crushed the competition. Its error rate was less than half that of the next best entry. It was a stunning victory that sent shockwaves through the AI community. The secret weapon? 2 NVIDIA GeForce GTX 580 GPUs. This was the big bang of the modern AI era. Suddenly, everyone in AI wanted NVIDIA GPUs. The demand from data centers and research labs skyrocketed. NVIDIA had, almost by accident, found itself holding the keys to the future of artificial intelligence. The bet on general-purpose GPU computing, made years earlier with CUDA, was paying off in a way no one could have imagined. NVIDIA leaned into its new role. They started designing chips and software specifically for AI workloads. They developed powerful data center GPUs like the Tesla, and later the A100 and H100, which became the industry standard for training and running large AI models. They built a massive software ecosystem around CUDA, creating libraries and tools that made it even easier for developers to build AI applications. This software moat became just as important as their hardware. The rise of generative AI, with models like ChatGPT, has only accelerated NVIDIA's dominance. Training these massive language models requires thousands of NVIDIA's most powerful GPUs running for months on end. Companies like OpenAI, Microsoft, and Google are spending billions of dollars on NVIDIA's hardware to build their AI infrastructure. NVIDIA isn't just selling the pickaxes and shovels in this new AI gold rush, they're selling the entire automated mining operation. This insatiable demand has sent NVIDIA's value into the stratosphere. From a company on the verge of bankruptcy to a key player in PC gaming, and now to the essential engine of the AI revolution. In just a few years, its market capitalization has exploded, surpassing tech giants like Amazon, Google, and eventually Microsoft and Apple to become the most valuable company on the planet. So, what's next for NVIDIA? They're not resting. They're pushing into new frontiers like robotics, autonomous vehicles with their Drive platform, and creating digital twins of entire factories and cities with their Omniverse platform. They see a future where AI is embedded in everything, and they plan to be the company that powers it all. The story of NVIDIA is a masterclass in long-term vision and strategic pivoting. It's about seeing a future that others don't, making a big bet on that future, and then relentlessly executing to make it a reality. From a booth at Denny's to the pinnacle of the tech world, it's a reminder that a powerful idea, combined with grit and a bit of luck, can truly change the world. It's a story that is far from over. Thank you so much for joining me on this incredible journey through the history of NVIDIA. If you enjoyed this deep dive, please hit that like button, and don't forget to subscribe and turn on notifications so you don't miss our next video. We love hearing from you, so drop a comment below, and let me know what you think is the most fascinating part of NVIDIA's story. Until next time, stay curious.